Hi everyone, this is Dr. Swaminathan SM. Now I am going to discuss about the topic CV characteristics. First of all, what is mean by CV? C means nothing but capacitor. V means nothing but voltage. So what is the relation between capacitor and voltage means charge is equal to capacitor multiplication with voltage. So Q is equal to CV. So that is the relationship between C and V. So first, the outline of today's topic is introduction, the mass capacitor, the mass characteristics, that is the measurement of mass characteristics, CV characteristics, the three types. First one, simple mass capacitance model, and second one, detailed mass gate capacitance model, and third one, detailed mass diffusion capacitance model. And next, the mass capacitor, following with the activity, the content too will be capacitance of mass device in three different modes. One is accumulation, and second one is depletion, and third one is inversion. Next, the CV characteristics and the diagrams, that is energy band, charge and mass band diagrams. Following with this, we will complete the assessment and summary. So next to the mass characteristics, CV characteristics introduction means, so measured the mass capacitance, that is gate capacitance, varies with the applied gate voltage. So based on the gate voltage, we can control the capacitance because both are interlinked. So the powerful diagnostic tool for identifying the any deviations, that is both oxide and semiconductor layer. It is routinely monitoring with the mass device fabrication, that is nonlinear and voltage dependent. So based on the capacitor behavior, it is averaged the switching voltage of logic gates. So this is the mass capacitor. So first one, look at this VG, that is nothing but gate voltage, and metal is like acted as a wire, and the oxide layer is silicon dioxide, and semiconductor is the last region and the grounded. So next VFB, that is a flat band voltage, and next the oxide voltage, that is depends on the gate voltage, same like silicon voltage, that is oxide voltage. So Vg is equal to VFB plus V oxide plus VSI. So these three combinations, that is called gate voltage. So gate voltage varies based on this three voltage. And next, the mass measurement of CV characteristics, that is nothing but measurement of CV characteristics. Apply any DC bias, the superimposed small AC signal is carried. That's like a frequency 1 megahertz, or it is varied based on the 1 kilohertz to 1 megahertz. Next, the DC bias, that is gate voltage, it is slowly varied based on the CV characteristics. So the three types, that is the simple mass, detailed mass, and detailed mass diffusion gate capacitance, that is based on the uh, types of the CV characteristics. So it is used to estimate the delay and the power consumption of the transistor. And next, the mass gate capacitors, that is the combinations to attract the charge to invert the channel high capacitance, that is based on the increase of the IDS. So the drain source, that is varied, the current is varied based on the above gate voltage, like a tap. So if you are varying the tap either open or closed, the current, that is the water flow is varied. So based on this drain source, that is having this, and above that gate, so based on the gate updation, you can vary the current flow between the drain source. So again here we will see the capacitors, that is CG, that is C per microns, W is width, and C per micron, that is oxide into L is the length. So C oxide, that is permittivity of the oxide divided by thickness of the oxide into L is the length. So C, G, C, D, C, S, that is gate, drain, source capacitance. It makes the circuit performance impact. And again it is called as a parasitic capacitors. So the diffusion layer, that is isolated, shared, merged. Isolated means that is varied, that is kept based on some distance. Shared means it shared the positions. Merged means it merged one and one another. And next, the detailed mass gate capacitance model. So C naught is equal to C oxide into WL. That is intrinsic capacitance means over the channel. Overlap means that is overlap between the source drain body. So body, another name is called substrate. And CGS, the overlap means CG overlap, that is CGS overlap capacitance into W, same like CGD. So the cutoff region means there is no current flow, so there is capacitance value is reduced. Linear means just we are given the current, so just channel is created based on the CGS equal to CGD is equal to C naught by 2. Saturation means just less than, that is VGS minus VT. VDS is greater than VGS minus VT. So the capacitance source voltage is 2 by 3 C naught. And next, this is the tablet column. You can easily remember that capacitance GGB, CGS, CGD. So both three, these combinations, that is called the gate capacitance. So for the different regions, already we discussed cutoff, linear and saturation. We will tabulate this three different capacitance for getting the gate capacitance. And next to the AS is nothing but area of the source, that is W into D. PS is nothing but perimeter of the source, that is 2W plus 2D. So here the total capacitance, this is the formula, that is the derivations, and CGBS, that is also the junction capacitance at zero bias, high process dependence. So MJ is the junction grading coefficient. So based on this, you can vary the CJB, SSW, SW means side wall, and again the side wall capacitance. These are all the two derivations for the side wall. So the mass capacitor, that is the three important formula. You can get CG is equal to CGB plus CGS plus CGD. So the gate is constant. The body is nothing but substrate and source and drain. So why we are using body means already S is included, that is for source. So to differentiate source and substrate, we can use the body. Okay, so VG is nothing but VFV, Vx plus VSI, already we discussed. So the capacitance of accumulation, so the small capacitance that is defined based on the derivation, that is differentiation of the dq by dv, and we consider the accumulation mode. So the high voltage, if you are given the accumulation layer, this thickness is very small. So we need to separate the metal and semiconductor based on the charge approaches, the thickness oxide. So C is equal to C oxide is equal to X long ox divided by X oxide. That is in the accumulation mode. Accumulation means it is joined one and one another. And the accumulation mode, you can see the diagram, that is gate is grounded and the source drain also grounded. So the three different gate voltages, that is gate electrode and substrate CGB, and gate between the gate drain and gate source. These are all the three different voltages based on the length and capacitance variations based on the given voltages. And again the depletion mode, we can use the depletion mode. Depletion means we are adding the impurities. Based on this, we can get the Vg is equal to Vfp, means it is disappeared. So suppose the charge is decreases, means you can disappear the capacitance for our convenience. That is called depletion mode. Inversion mode means that they respond to the measured voltage, it inverse. For example, plus 5 voltage if you are given, the minus 5 voltage if you need, means you can vary the inversion layer. That is called inversion. So this is the different characteristics diagrams based on the accumulation, depletion and inversion mode for getting this different values. So first one is the non-ideal and the second one is the ideal CV curve. And the energy band diagram, for first look at this, Vg is equal to Vf, that is same. The gate voltage and flat band voltage both are same, means this is a voltage, and again you can get the Vg less than Vfb. Less than means just increase the gate voltage. Again if you are increasing, means that is Vg greater than Vt, means it neglected. So the reference voltage, that is called the threshold voltage. Based on the threshold voltage condition only, we can get the active region. Okay, that is the condition. So again the charge diagram, charge means that is plus q and minus q, we can use for based on the flat band diagram. Accumulation and depletion and inversion layer, based on the charge, positive charge and negative charge, we can get the different layers. And the mass band diagram for accumulation, greater than, that is gate voltage is greater than, so the electron is accumulated on the surface. Depletion mode means less than, so electrons repelled. Repelled means that is moving reversely from the surface. And inversion means that is surface becomes the p type, that is if n type means it is converted into p type, if p type means it is converted into n type. So this is the mode of operation, the assessment period. So assessment time and the summary time, we can get these three different modes, accumulation and inversion and saturation modes. We can get the different regions of operations, the capacitance of the different MOSFET, and the gate voltage based on this cutoff and linear saturation conditions. We have tabulated that voltage. So these are all the MOS CV characteristics. Thank you.